Welcome to the Stormsurf video surf forecast for the week starting Sunday, May 13th. We are officially switching now to the southern hemisphere. The northern hemisphere, for all practical purposes, is out of business and all activity of interest is down south now. Looking at significant wave heights, we see remnants of a gale, still producing 32-foot seas aimed northeast. Other than that, rather quiet pattern, but not really. There's been a whole series of storms pushing under New Zealand. Let's get into the details. As usual, we'll start this week's presentation looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough. Now that we're in the southern hemisphere, troughs push to the north, and that helps create a clockwise flow down at the ocean surface, and that is the hallmark of low pressure. And of course, low pressure generates winds, winds generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, creates surf. So there is actually a small trough. Here's New Zealand, there's Australia, Antarctica down here, South America right there. Little bit of a trough pushing north, being fed by 140 knot winds. Let's see if it does anything. No, kind of little bit, moves east. Then a new batch of wind energy starts developing on Monday, 140 knot winds. And there we go, a little bit more organized. Now, typically in the southern hemisphere, the troughs are not as well defined as they are in the northern hemisphere, but still every bit as productive, but you sort of need to recalibrate a little bit and not expect as obvious a picture as in the north. Anyways, we get into Tuesday, trough is still present, pushing southeast, being fed by 120, 130 knot winds, lifting north, and then starting to get cut off as we get into Wednesday, and then pretty much out of the picture and cut off. And then what do we have? We have, again, you typically get this sort of a split flow. The southern branch down here running either over or south of New Zealand. The northern branch, somewhere between 20 and 30, sort of meandering across. And that's pretty much a typical kind of pattern. We're looking for another trough. We see sort of one trying to organize on Saturday under New Zealand, but not very organized. It gets cut off too. We're out 168 hours, 180 hours. So not a whole lot suggested after the trough that's forecast to traverse the South Pacific in the next couple of days. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. Little gale is present here, southeast of New Zealand. In that trough that we saw, 35 knot winds pushing up to the northeast. You really want the winds to push as northeast as possible, if not to the north, to push swell up towards California and Hawaii. And relative to Hawaii, well, Hawaii's at about 155, 158 degrees west, so really, this area, the New Zealand corridor, is prime for Hawaii. Storms need to push under New Zealand and then lift to the north to be of prime interest for Hawaii. You can get by with a sort of a gradual northeast drift relative to California. And of course, Central and South America, even if a storm's just traversing almost straight west to east, swell will radiate to the north into those locales. Anyway, so here we go. The gale reorganizes on Monday, 45 knot winds lifting off to the northeast and building to 50 knot winds midday, and even a little tiny area of south winds at 55 knots Monday night. This is of interest. It's not a huge system, and it continues into Tuesday morning, then starting to fade with 50 knot winds. But notice it's on a sort of a northeast trajectory, the whole storm, continuing south winds at 40 knots even into Tuesday night. And then the whole system sort of lurches north a little bit and starts fading as we get into Wednesday and then dissipates. Another system tries to organize under New Zealand, 30, 35 knot winds. But remember, from this position over here, you're 6,600 nautical miles away, whereas relative to California in the northern hemisphere, if you're on the dateline, a storm on the dateline, that's only about 2,400 nautical miles into California and less to Hawaii. So you need much more seas, more wind energy to generate those seas for the swell to survive the triple the distance journey up into California. So we're looking, you really want 40 to 45 knot winds at a minimum. We're seeing 35 knot winds. There's some 40 knot winds pushing south as we get into Friday and Saturday. And then we'll just sort of roll it out. Things looking pretty quiet after that. So we're going to go back in time to last Sunday week. That's when this whole storm pattern started developing under New Zealand. Small, we'll call it a primer gale, developed. 36-foot seas pushed under New Zealand, and you go, hey, that's not too bad. A little bit of a system, but really what the system did was just sort of rough up the ocean's surface here, because another gale storm developed right behind those winds from that system, got traction on the already chewed up ocean surface, and so whatever winds this system had could impart their energy into the ocean much more efficiently. And as you can see, as we got into 06Z on Tuesday, that area there, 57-foot seas, there was adjacent to Satellite Pass, and here that is. Here's the actual satellite track right here. It went over the east quadrant of the storm, not even over the core of it, just over the eastern tip of it. And average measurement, that's 15. So you can, if you look very close, you can see tiny little lines running through there. Each of those little colored lines is one pass by the altimeter. We go through all this data, find the 15 consecutive readings that have the highest value, and it happens to be sitting right there, and that is 47.4 feet. And within that little sector, you can see that one little bit of yellow right there, a single measurement came out at 55.6 feet, and that's not even in the core of the storm, which supposedly had 57-foot seas. So, if nothing else, the model was conservatively spot on, if not undercalling it a little bit. That's good news. Anyway, back to the Hindcast. That system pushed under New Zealand. The swell window relative to California, even back here, some of this energy radiates right up the side of New Zealand here, about 220, 221 degrees into California. So really, though, this is where the swell officially was best in the swell window, that 12Z on Tuesday. Anyway, that system pushed east and faded out. And then here we go. Another system tried to develop but faded on Thursday. And then yet another system just Saturday, yesterday, developed under New Zealand, built a little bit, tiny area, 40-foot seas, and then started fading some as we got into Sunday. But the forecast, well, you'll see in a second. And then here we are, the forecast charts. You see the system fades, and then a new fetch develops behind it. It starts getting reasonably respectable come Monday with a tiny area of 39-foot seas. It says 40-foot, but it's about 39 feet, we'll say. And then building to 45 feet and to 50 feet at 6Z on Tuesday, holding into 12Z on Tuesday, and aimed reasonably well northeast. The cutoff for the California swell window, Southern California about 117, something like that, and Northern California about 122. So well in the swell window, not aimed optimally, but not horrible either. Continuing till late Tuesday with, what is that, about 42-foot seas, while another system pushes under New Zealand as well. And then finally, our system still in the swell window continues Wednesday with 34 feet, and once you get up here to about 40 south, the system gets very close, and decay becomes a bit of a less of a factor, but the system is to be fading at that time too, and moving out of the swell window, while the next system pushes under New Zealand, but is not expected to make it under New Zealand, past into open Pacific and do a whole lot. And then we'll just roll the model out here, and you can see things settle down. So the short of it looks like a whole series of swells are expected, none of them huge. The two that went under New Zealand, the primer gale and the main gale after that, the biggest one, good longer period energy, but size is to be pretty modest. Relative to Tahiti, yeah, they're supposed to get some good solid swell, but relative to the U.S. West Coast, probably nothing huge, but at least a start to the summer season. Now, the one that's supposed to push further north later in the next couple of days, was that Tuesday, Wednesday sort of time frame, maybe a little bit more size, a little bit more of a southerly angle. But anyway, after that, then things are to settle down. But it's a nice start for summer. A quick look at the northern hemisphere. Yeah, tiny little gale is occurring right now in the northern Gulf of Alaska, 18, 19-foot seas, aimed mainly at Alaska, northern Canada. Not a whole lot expected from that. And then we'll just sort of run through this tiny little area, 18-foot seas on Wednesday. Nothing is expected from that of any, no swell of interest. And then things really settle down. By then, we're into the second third of May, almost towards the end of May, and it would be normal to expect that the North Pacific would go to sleep at that time. Do a real quick look here at winds relative to California and Hawaii. Light trades for Hawaii, a little bit of northeast, maybe wind swell, maybe occurring right now. And that due to high pressure north of the islands, but nothing particularly inordinate. California, light winds expected, and it just kind of goes that way. No strong high pressure, low pressure going through the Gulf of Alaska, kind of putting a squash on things till we get into Friday. High pressure starts building into the U.S. West Coast, 15-knot winds, and up to 20 knots near Cape Mendocino. Good for maybe some very limited, junky, short-period wind swell. Also, some easterly trades start building later Friday relative to Hawaii, also associated with this 1026 millibar high northeast of the islands. Trades continue, and north winds relative to California, mainly for northern California, but no serious gradient developing. Another low pressure moving into the Gulf at that time on Sunday, and there you have it. So, modest easterly at the best wind swell for Hawaii, and probably less than that, just short period wind junk really for California for the week. Long term, what's going on with the MJO and El Nino, La Nina? Let's go see. As usual, we like to monitor what's going on with the Madden-Julian oscillation. So when the Madden-Julian oscillation is in the active state, it doesn't have as direct an impact on the southern hemisphere as it does in the northern hemisphere in winter months. But still, it's something to monitor, especially strong active phases of the MJO can help promote El Nino. We don't expect to see any of that, but still, we're very fixated on the MJO just the same. So, looking at winds across the equatorial Pacific, specifically in an area we call the Kelvin wave generation area from 135 east to 170 west. Draw a box 5 degrees north and south of the equator. Here's the date line right here. East Pacific here, West Pacific there, New Guinea there. This is data from the TAO buoy array, a series of buoys strung across the equatorial Pacific, used for monitoring El Nino. Actual winds from the east, pretty brisk, but that's kind of normal for this time of year. In the Kelvin wave generation area, a little bit out of the east now. All right, anomalies, differences from normal for this time of year. Yeah, these easterly winds you're looking for the arrows here. They're non-existent, meaning dead neutral. This is a normal sort of situation. We see a couple of small arrows out of the east here in the Kelvin wave generation area. That means light easterly anomalies, probably indicative of the inactive phase of the MJO. Dead neutral winds or lightly from the west or strong from the west suggests the active phase of the MJO. So the MJO is really not in play. Looking at wind anomalies for the past 5 days, there's South America, there's Australia, New Guinea right there. Kelvin wave generation area, basically draw a little box right there. You see the oranges and see the arrows. That means westerly anomalies. That was on May 7th. Same thing on the 8th. The 9th getting weaker still into the 11th, suggestive of the active phase of the MJO slowly fading. And you can see that too on this chart here. This is the whole planet on one chart, and going back in time, the Kelvin wave generation area, between these two tick marks, just displaced a little bit to the right here going down. The reds and yellows suggest westerly anomalies, the blue easterly anomalies. So in the Kelvin wave generation area, just looking down here, yeah, good part of April, we had westerly anomalies in the active phase of the MJO. But then just in the past 2 days, here's May 13th today, we see some weak easterly anomalies starting to show up, the blues. And as we go down, looking at the forecast for the week, pretty much that stays. If anything, easterly anomalies to build a little bit strong over a tiny little area right on the date line. So this would probably be roughly indicative of the inactive phase of the MJO. Looking at outgoing long-wave radiation prediction charts. So this is a little bit different. This predicts sunlight reflectivity off the ocean surface. Also a way of saying presence of clouds or lack of clouds. So reds and oranges mean a lot of sunlight reflectivity, meaning no clouds, meaning high pressure, meaning the inactive phase of the MJO and the Kelvin wave generation area, right in that area. And you can see this, per the statistical model, suggests the inactive phase holding for the next 15 days, but fading late in the period. The dynamic model basically saying the same thing, but with the inactive phase not making much eastward headway, instead just weakening over in the far West Pacific. Phase diagram charts, another way of watching the status of the active phase of the MJO and its relative strength. So assume you're looking down on the North Pole here. The MJO travels from west to east, from the Indian Ocean over the maritime continent. Consider that like Bali in that area. And then across the West Pacific, across the dateline, under the United States, across the Atlantic, through North Africa, back to the Indian Ocean. Round and round she goes. Where the heavy dot is, that's where the active phase of the MJO is right now. These other lines here, forget the yellows and the greens. This is where it has been. Okay, so let's see, where does this, it starts here. And what was that, the 3rd of, just looking real close, March, going the whole way through here, whole way through March, into April. Oh, no, I'm sorry, that was, April into May. Here's where we are right here. And then the next 15 days, the track. The further away from the circle, the stronger the MJO is. So a moderate, strong, I'll say moderate MJO, somewhere probably over Africa, moving towards the Indian Ocean in the next 15 days per the ECMF model. Per the GEFS model, basically the same sort of track, maybe a little bit weaker. So no real good sign of the active phase of the MJO in the Pacific corridor is forecast. 40-day upper level charts. This goes out 40 days, gives you a little bit longer lead view, and the oranges suggest dry areas, not favorable for precipitation. The greens, areas favorable for precipitation. So there's New Guinea there, Kelvin wave generation area, basically right in about this area. So we see dry air through and moving east into Central America through about June 2nd or so. That would be the inactive phase of the MJO. Then the active phase is supposed to show up pretty strong in the West Pacific come the end of May, making its cycle across the Pacific into about June 22nd or so, and then another pulse of the inactive phase of the MJO after that. I think we said it last week. The average periodicity on MJO traversing the Pacific has been 41 days. Then our favorite model, the CFS model, Kelvin wave generation area, basically between these two tick marks. Now we're going back to January here. See there was a strong, the yellows and the oranges suggest westerly anomalies. The active phase of the MJO, strong active phase of the MJO at that time. Another little tiny pulse there in the late March, early April time frame. And then here is our most recent active phase. We're just looking at this, we're not cheating. We're just looking at the based on wind conditions. Say, okay, we're just wrapping up an active phase, but there's no signs of a strong inactive phase at all for the next 3 months. But let's go see if that's correct. And here we go. Here's our active phase, the solid contours fading out. Here comes our building inactive phase, but notice westerly anomalies in the heart of the Kelvin wave generation area, even during the inactive phase of the MJO. That's a very good sign. And then a stronger active phase forecast as we get into mid-June or so, and pretty much going the whole way through June into July, and maybe even some beyond that. That's good news. Let's take a look at the low-pass filter here. This is the good thing. So the solid contours are what we call the area biased towards low pressure. The dotted contours biased towards high pressure. In January, this past winter, notice the area biased towards high pressure, which you can basically interpret as La Nina, was sitting right over the date line, just stepping on the Kelvin wave generation area. If you wonder why this winter wasn't very good in the northern hemisphere and the Pacific. That's why La Nina and the high pressure bias wasn't favorable for storm production. But notice, as we get, here we are May, the low pressure bias is now filling the Kelvin wave generation area. Notice a second isobar building too, and even a third contour as we get into the June time frame. That suggests a far more favorable environment for storm production, not so much this summer, but maybe as we get into the fall and the winter. All right, so much for the MJO. Let's go see longer term what's going on in the ocean, specifically relative to La Nina and El Nino. Big development this week. So this is data from the TAO buoy array, East Pacific here, West Pacific here. Little X's are the sensors on the TAO buoy arrays used to gather temperature data. Warm water, 30 degrees centigrade. Now developed in the West Pacific. The key here is the 28-degree isotherm. There's the date line right there. This line has been locked solid on the date line for months and months and months. And then last week it made a break, and now it's past 170, almost, not quite to 165 yet, but about 167 or so, and building to the west. That means that warm water here is starting to push off to the east. What that also means is the trades aren't blowing as hard, and there's not cool water as much, or as much cool water in here, meaning that La Nina is dying, and that all has to do with that bit about the high pressure bias and the low pressure bias. Well, low pressure is starting, the atmosphere is biased towards low pressure here. That allows the trades to back off. That allows warm water to start pushing to the east. Here's anomalies, differences from normal for this time of year in water temperatures. And what we see for months, we were seeing a giant pool of cool water here. It's all gone. The big active phase of the MJO, when was that? Back in February or so, has produced a strong Kelvin wave. A Kelvin wave is warmer than normal water pushing off to the east. You can see it now. A river of 3 degree centigrade, warmer than normal water, pushing off to the east, pushing into the Galapagos and Ecuador in this area. Right there, that's the last little pocket of La Nina's cool waters, and that's normal to maybe a half a degree below normal, and only one tiny little pocket, meaning that La Nina, at least according to this data, is all but dead. Another version, the GODAS data, also clearly depicts that Kelvin wave pushing off to the east. Here's the last little bit of La Nina's cooler than normal waters, very tiny little area. Now, we did some digging into this. We've been keep waiting for this Kelvin wave to push off to the east and erupt at the surface here, and there's some suggestion that maybe it's doing that right at 100 west, but not particularly strong, and some of the science community is suggesting that the Kelvin wave is actually stalled, and that it's sort of not really going to make a major push up to the ocean surface. It might just sort of sit here and slowly lift up and warm in general, but not create some sort of a massive warm slick on the ocean's surface here. Hard to tell. We'll continue to watch. Upper ocean heat anomalies. This is the upper 300 meters of the ocean surface. West Pacific here, East Pacific here. We're going back in time. Here's our La Nina cool pool from August of 2017 into about mid-January of 2018, maybe a little bit past that. A weak Kelvin wave pushed across in the January time frame, upwelling phase of the Kelvin wave cycle. Then here's our big Kelvin wave that started in February. Here it is. It's made it about this far and seems to have stalled. Again, waiting for eruption on the surface, but that may not occur at all. Next up, let's take a look at the ocean surface temperatures. Differences from normal for this time of year. So we showed a small pocket of cool waters hanging off of Peru, Ecuador. You can see that right here. Much smaller than it's been in the past. Now there's been this sort of generic warming thing that's going on over the Galapagos, south out to down to about 10 south, out to 100, maybe 105 west. So this is, we think, the weak partial eruption of the Kelvin wave area there. And then we see much warming over the equator. Now, this used to be like 3 degrees north of the equator. Now it's sunk down to maybe 3 degrees south of the equator. So the Nino 3.4 region, the official area for monitoring El Nino, starts at 120 west, 5 degrees north and south. So from here up to about here, and then on out just to 170 west, so just off the edge of the picture here. And you can see warmer than normal water is filling a good portion of that area. We'll get into that in a minute. A little bit more encouraging data here, 7-day trend. If you look very close, you see yellows. That means warming, not much warming, just a little bit off the coast of Peru and just here around the Galapagos. Now, the big news here is warming, 7-day warming trend, starting about 105 west and filling the entire Nino 3.4 region. Look at that, all right there on the equator. That pretty much is the death of La Nina. And here's the backed off view. You can see it better. There's the last little bit of cooling off of Peru. And, you know, you'll continue to have cooling there. Trades blow pretty good out of the south this time of year along Peru. You get a lot of upwelling. That's not unusual. Cool waters. But compared to normal, we see much warming north of the equator and a little bit south of the equator. This is the last little bit of La Nina's cool pool here. Okay, displaced south now, well off the coast of Peru, and nothing in the northern hemisphere at all. In fact, let's look at temperatures here. The Nino 1.2 region, this is the area right there around the Galapagos, Peru, that sort of thing. You can see the trend. It was pretty cool at one point, one individual reading down to almost, 2.4 degrees below normal. But normally it's the averages that we look at. The trend now, you can see, is heading upwards. Right now, today's value, 433 above normal. So things warming a little bit in the Nino 1.2 region. And in the Nino 3.4 region, today's value, minus 0.198 right there. So almost neutral. You can see, you can draw a line through this. You can see slowly it's creeping up as warm water starts building into this area on the equator in the central Pacific. Just going to take a while, but we're close to there. Once you're above, your average is above minus 0.5 of a degree for 3 consecutive 3-month periods, then La Nina is considered dead. We're basically moving in that direction. There's no sign whatsoever that things are going to get cold again. Yeah, it might dip down for a couple of days cooler than normal, but for the most part, the trend looks like we're rapidly approaching normal temperatures in the central Pacific, and that would mean the end of La Nina. So what's going on in the atmosphere above the Pacific? All right, outgoing long-wave radiation anomalies. We're looking for presence of rain or lack of rain. The yellows suggest areas of less than normal precipitation, more sunshine. And the blues would be greater than normal precipitation. So we still see the lingering bits of La Nina here. It's really mainly just on the equator we're interested in, mainly in the Nino 3.4 region right in here, but also, mainly in the Nino 3.4 region right here. So we see normal to drier than normal conditions. We know temperatures are a little bit, water temperatures are cooler than normal in this area, still south of the equator, and that, since they're cooler, less evaporation, less rainfall, and that's the typical lasting after effects of La Nina. We also can look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. The daily value today is minus 10. Long runs of negative numbers suggest at least the active phase of the MJO. We're not seeing that. We see scattered negative numbers, but not a lot of them. It's sort of a mixed bag, almost kind of neutral, on and off, positive and negative. The 30-day average, that takes some of the noise out here, says minus 4.09. Now we know we're just coming off the active phase of the MJO, and if we're moving towards the inactive phase, it would stand to reason this number, if anything, might not go much further negative and might start trending upwards towards zero. The 90-day average, this you can use to look at La Nina, El Nino sort of thing. We're at 3.64 today, and we've been hovering right around there for the past couple of days. The MJO has some effect on these numbers, but basically we're just basically a notch above neutral, so slightly biased La Nina. The expectation is this will go to zero here in the next month or two, something like that, as the last of that cool water, La Nina's cool water, returns to normal temperatures, and then we start getting normal precipitation in this area, and then we'll see everything zero out. And then the question is, where do we go from there? Also looking at the ESPI index, again, it's precipitation, not pressure now, in the area north of Darwin, Australia, and north of Tahiti. The negative index means less than normal rainfall, meaning drier conditions right in this area, and we're at minus 0.57. So we were up to minus 0.38, I think, 2 or 3 days ago. Dropped off significantly just the past day or two. But again, all these indexes are kind of noisy. It's the long-term trend that you're interested in. This is the last 30-day average. The expectation here still is this will continue to creep up and eventually reach zero, which would be normal. And then you can say atmospherically, La Nina is gone. Right now, in the ocean, La Nina is fading quickly, and effectively it's gone. But the atmosphere above it takes quite a bit longer to sort of respond to that change. It's a global weather pattern, El Nino, La Nina is. So the boat doesn't turn that quick. It'll take several months for all this to happen. But as we get into the later part of summer, we would expect to be back in a normal configuration, and then moving into fall, maybe something a little bit better. And then finally, the CFS forecast for surface temperatures in the Nino 3.4 region. So where are we? We're right around here in May. You can see by the time we get to June or so, temperatures are forecast to be neutral. There's zero. And then as we start working into later summer, creeping up in October, maybe a quarter of a degree above normal, and then maybe a half a degree as we get into the January time frame. This is probably the more conservative of all the models. The rest of them suggest maybe a little bit more, to maybe 0.8 of a degree above normal, and that would be in El Nino range. And a lot of the models, right now I think the official forecast is 50 to 60% chance of a weak, barely noticeable El Nino for the coming winter. Probably more like a Modoki El Nino sort of thing, which really doesn't do anything one way or the other. For all practical purposes, you can say it's a normal year biased slightly towards lower pressure in the Kelvin wave generation area, slightly towards El Nino, but not a full-bore El Nino. We don't really want one yet. We need the ocean to... We're in recharge mode right now. More heat needs to build up in the ocean so that we get a significant El Nino. But, you know, the atmosphere tries to balance out heat and cold, and right now it's in recharge mode. So to wrap things up, North Pacific has gone to sleep. Fortunately, the southern hemi is waking up. Small series of swells expected, maybe something a little bit larger. There's a decent storm forecast to build in the central to southeast Pacific over the next couple of days. Maybe a little bit of larger swell will come from that. It takes about a week to radiate north into California and Hawaii or so. So we'll keep our eyes on that. Then after that, things quiet down a little bit. Pretty typical this time of year. Wind swell to fill the gaps between the southern hemi swell. That's the strategy. Long-term outlook, MJO kind of weak, kind of not doing a whole lot, but the ocean is getting reconfiguring itself from La Nina. La Nina, for all practical purposes, is dead. The forecast says normal to a normal bias, slightly El Nino-ish for this winter. So things are looking good. Get some surf. Get what you can. Prepare for a normal winter to come after that. Do this again. Thanks for watching. Do it again next week. Same time, same channel. Thanks for watching.